Hello students. In previous sessions under module 4 we have seen all our sorting algorithms, right? In this session we will see very basic search techniques. One is sequential searching and another one is binary search. Both we will try to cover in this session, right? So what are the sorting algorithms we have covered? Bubble sort, it will bubble up with the biggest element. Selection sort, insertion sort, it's like playing chords. It will insert element in its appropriate place. Selection sort, it will select the smallest element and it will keep in the proper place. Radix sort, based on the least significant digit to most significant digit, it will put in the respective buckets and it will do the sorting. Quick sort, it will try, first it will choose the pivot element and it will try to sort the elements which are left side of pivot should be lesser and right side of pivot should be greater. In that concept it will do, and you have seen examples also. Merge sort, another divide and conquer technique. Shell sort, it is nothing but generalization of insertion sort. First we will divide the array into subarray with the specific distance, then we will do the sorting like insertion sort. Heap sort, nothing but we have to build a heap, and then we have to create whether max heap or min heap based on the order, whether we have to sort in ascending or descending order. Then by continuously removing those elements we can get the proper sorted order, right? The next topic is searching. So searching is very important concept where whatever it is a file or any data we are searching, any image, anything queries, anything can be related to the searching, how the search should be, that is in minimal time, right? I should search an element or an item in a minimal time, and of course that algorithm should use minimum number of memory, because whatever we have seen with only few number of elements, 5 element, 10 element, just an example we are saying. But whereas in real time, for example, you are just typing in Google, so in a second we are getting those many results, right? It's not that much easy to get the sorted elements, right? But the basic idea is we have to get the results in minimal time, and also my algorithm should utilize minimum number of memory. So 1000, for example, 1000 elements I am storing before searching. So that searching algorithm should not take too much time. Also, it should not take utilize so much memory also. Okay, in both term we have to be very careful. So just basic searching technologies we'll see. One is sequential or linear search. By the term itself, we could understand what is sequential or linear search. That is, we are searching one by one. Linearly, we are searching, right? And when we can tell the search is successful, that is, we are searching for an element. If that element is found, that search is successful. If element is not at all found in that given list, it means it's unsuccessful. Okay. And I will come to a linear search. What it will do, it will search for a key element in the given list by comparing with every element of an array, right? So each element is compared with the key element. Key element is nothing but the key which we are going to search. It will start comparing the key element with each element in the given array till the end. Okay. If the element is found, yes, it is found. Until the end, if it is not found after searching, then that particular element is not there in our given elements. Okay. So by general, how we can tell, linear search takes n comparisons for an array consisting of n elements. For example, I'm having 10 elements. Okay. I want to search. So by general, it is not that always n comparison, but by general, how many comparisons I have to take? N comparisons. We will see one simple example. So we'll consider the unsorted list. So many numbers were there, nearly 12 numbers are there. Okay, so what is my key element? For example, I want to search 45. Okay, I want to search 45. So what is the linear search algorithm? I will start searching from the first position, right? So I'm just checking whether 45 is my key element now. 45 equal to 45. Yes, very good. I have found my element in the first attempt itself, right? So I'm just entering, I'm just starting executing algorithm. Yes, very good. In first attempt itself, we have found. And next, I'm giving my search element as 39. So what my linear search will do, it will start searching with first element, whether 45 equal to 39, no. Then I'm checking with second element, whether 39 equal to 39, yes. So 39 will take, is comparing 2 times to find that element. Now, if my key element is 8, so what my linear search will do, it will start with the first element, whether 45 equal to 8, no. Next element, whether 39 equal to 8, no. Whether 8 equal to 8, yes. So to find this element, it needs the comparison and so on. For example, my searching element is 20. So how my linear search will do? It doesn't know whether my element is last, middle, nothing it knows, right? So what it will do? It doesn't know anything. So as usual, it will search 45 equal 20, no. 39 equal to 20, no. Whether 8 equal to 20, no. And so on. Finally, 20 equal to 20, yes. That is, we found our element. Here, this algorithm is very simple to implement, very easy to understand, but it has some drawbacks also. Okay? When more number of elements are there, for example, 1000 number of elements, I'm searching one key element where it is present in 900th place. So what will happen? You just imagine how many times it will run. 900 comparisons it will make, right? Understood. And we'll see with second example. Just elements are minus 15, minus 6 and so on. Index, array index, we have to represent an array, right? Array index nothing but starting with 0 till 8 it is there. So I want to search key element 7. I want to search number 7. So we will start with 5. So 1, it is not equal, 2, it is not equal, 3 and 4. It found at the third position. But search is successful. I am searching for 82. Again, it will start with first position, continuously checking. Yes, my data is found. Found at the 7th position. I am searching for 42. What will happen? Start from the beginning, it is searching till the end. Unsuccessful. Just imagine again, if 1000 number of elements are there, I am searching one element which is not present in that list. So what my algorithm will do? It will search one by one till the end, right? So it have this drawback also, but very simple algorithm and easy to understand. So to overcome this number of searching, to overcome the number of, reduce the number of comparisons, we can go with next algorithm. That is nothing but binary search. Okay. So how this drawback can be overcome with this algorithm, we'll see. So we'll revise the recap. What is linear search? A very simple algorithm. It will search an element one by one from the beginning till the successful search, and it will do comparison till the end for the search. Till then, if the element is not found, then it is unsuccessful search, right? That's all. And we will see with the binary search algorithm. Okay. Binary search. The term itself we can find where we are going to divide into two, right? So what we are doing, we are given with array of elements. That array of elements, what we are going to do, we are going to split into two, okay, with some condition. Okay, before that, we have to do one step before searching. What is the important step? We have to sort the given elements. Okay, we have to sort the given elements. So here we need one more extra step. we have to use some of the sorting techniques and we have to sort the given elements. After sorting, we can apply the binary search procedure. What is the binary search procedure? If the we will see with one example so that you will understand. See, for example, I have 3, 5, 7, 9, 13, 15, 18, 20. Okay, where the elements is already sorted, right? So now I'm searching. Now my key element is my key element or the search key is number 18. Okay, number 18. Since the given elements are already sorted, I'm searching for 18. So if it is linear search, what it will do, it will start with 3, 5, 7, like that it will go. But here what I'm doing, I'm just trying to find the mid element position. Okay, mid element is 3, 6, totally 8 elements are there. So mid element is, I can choose here. For example, 13 is my mid element. What I'm doing, I'm comparing with this mid element whether the key element is lesser than mid element or greater than mid element. Whether it is lesser or greater, key element is greater than the mid element. So obviously, where my key element will be there, search element, obviously it will be there right side of my mid element, correct? So here we are just skipping half of the array. Half size of the array we are just skipping. Whereas in linear search, we have to search all the elements, right? Till the search becomes successful. But here we are just truncating half of the array in the first step itself. Okay, so I can search only 15, 18, 20 instead of searching completely because I am damn sure that my key element will be left side of my mid element because it is already sorted, right? Okay, so this is the algorithm. Initially, we have to mention with low value and high value. We are checking with whether low is not equal to high like that. And mid, first step, we have to find the mid value. Mid value is nothing but low plus high by 2, that position. And we are checking whether the key element less than E of mid. What we are doing, we are changing the high index value. If it is greater than mid, we are changing the low index value. Nothing but we are just limiting the search space. If both not, then we can return the mid value, right? We would check with one example. We'll see one example. I'll just put in yes, we will see with one example. Same example we'll take. Okay. We'll copy the algorithm also. So we'll consider this example. Okay. So we are having 12 elements, and for easy purpose we started the index with 1. Okay, we'll start doing. So what is the first step? We have to mention low and high, right? So low pointing to the first position, that is our low pointing to the first position initially, and high pointing to the last position. This is initially. High pointing to the last initial step, right? Still we didn't find the right, or for simply we'll put H. So initially low pointing the first element and high pointing the last element. That is, we are maintaining the index, right? And what is the next step? We are just checking low less than or equal to 8. Till low less than or equal to 8, we are doing the procedure. Whether low less than or equal to 8, what is the low index here? Just we are checking the index, not the value, index. 1 less than 12. Yes, it is true. We'll proceed. What is the next step? We have to find the mid value. Okay, so low is also there. Low index and high index, and mid is value. That you should not get confused. Mid value you are considered, mid position we are considering, and low is also index or position. All are pointing the index. So what is low index? 1. What is the high index? 12. Then mid we are finding low plus high by 2. We are doing the floor method. That is, it will slow down to the nearest integer. Right. So what will happen? It will give the value 6, right? So 1 plus 12, 13. 13 by 2, 6. That is, we are taking only integer part. Okay. And we have got the mid position. So where is our mid position? In the 6th index, right? Now our mid is pointing here. Okay. I'll just write our mid is pointing here. What is the next step? I'm just checking. Maybe our key element we can take, for example, we'll consider x is equal to 4. X equal to 4 itself we'll consider. How much comparison it will take, we will see. Or some other element with less number of comparison. Okay, first we'll start with x equal to 20 itself. Okay, and as now our key element is 20. Okay, so now we are going to start the procedure. So I initialized low, I initialized high, low index to the first position, high index to the last position, and I found the mid value. And I want to search the element 20. So what is the first step? I have found the mid and I am checking key. Key element is nothing but x. Okay, here x. Nothing but in our program it is x. Okay. And I'm checking whether x less than a of mid, whether 20 less than a of mid. A of mid is what? 20. Whether less than a of mid? No. Whether greater than? No. It means what? The number is equal. It is not less than, it is not greater. Obviously, it is equal to that number. So, in one search itself, we got found our successful search. But if it is linear search, so how many comparison we have done for key equal to 20? We need only one comparison, right? Okay. Next, we will take key element as key element, or we will consider x, because in program code in algorithm x is 4, that is first element. Okay, x equal to 4. And what is our low value? Starting index. What is our high value? End index 12. And we have to find the mid, obviously 6. Okay, now we are checking whether 1 is less than 12. Yes, it is true. We found the mid. X less than mid, we are checking. What is x less than mid? X is what? X is 4. Here our key element is 4. Whether 4 less than mid, we are checking. Right? 4 less than mid value. That is value in its position. Whether 4 less than 20, we are checking. Whether it is true, inside we are checking whether x less than a of mid. A of mid is what? Now mid is our 4, right? So I will just, now our mid position is 4, not 4, 6 only. Still we didn't start checking, right? So I'm just checking 4 less than a of mid. A of mid is what? As now 20. Whether it is true? Yes, true. If it is true, what we can do, what conclusion we can get, that is the element which we are searching definitely will be left side of our mid element, correct? Because it's less than my mid element, so obviously the element which I'm searching is the will be reside in the left side of my mid element. So that is, I have to concentrate only on these portion, because definitely my element won't be here because the elements are already sorted. So since my element is lesser than my mid element, definitely my searching element will be residing here. So I can restrict my search space here, right? So what I'm doing, this mid position I can, that mid position I can use to find the, to place the last position, that is high position. How I can make, see, this is the area where I have to limit starting element. So mid element is what? Now the last element I can keep here, right? Because I don't want to search in the second half, right? So since it is true, so where I want to search, I can search the variable height. That is, here we are mentioning height equal to mid minus 1. That is nothing but 5. So now I don't want to search complete array. So low value is 1. Now high value became 5 because it is enough to search in this position. And what is the next step? Again, it will come here. Low less than or equal to high. Yes, 1 less than or equal to 12. Fine. And what we have to do? We have to find the mid value. So now mid value will change, right? So mid value is equal low plus by high. My low changed and high also changed. Low is not changed, high changed. So low value is 1, high value is what now? 5. So 1 plus by 5 by 2, nothing but 3. Now mid is 3, right? So now I have to shift my mid element to third position. That's all. See, I'm nowhere concentrating on the second half because I know that my value definitely reside in the left half, right? So what is the next step? Again, I'm checking with the mid element. Whether my less than a of mid, that is 4 less than 8. Yes, that is true. That is, I'm checking with the mid element. I'm checking with the mid element. 4 less than a of 8. It means what? My element definitely will be residing left side again. So again, I'm changing the high variable. Again, I'm changing the high variable to mid minus 1. So I will change my high variable to mid minus 1. So at this step, what will happen? Low equal to 1, high equal to 2. So I have to find mid. 1 plus 2 by 2, 3 by 2, that is 1, because we have to consider only integer part. So now I'm checking. So now my mid will become first position. Right, now I'm checking whether a x less than a of mid, 4 less than 4, no. Whether greater than, no. So what will happen? Just it means we got the result. The mid value is nothing but our search element. So we are returning mid. Understood? So this simplifies the searching procedure. It reduces the number of comparisons, right? But it have little drawback also than comparing linear search. Here we have to sort the elements. That is the first step, right? Before doing searching, we have to do the extra additional step. That is, the element should be sorted. Then only we can proceed with the next, right? And once the element got sorted, we can start the procedure. You have to initialize low and high variable. Low is the first starting index, high is the last index. And what is the first next step? You have to find the mid position. And you have to cross check. You are comparing your key element with mid position value. Okay, the value in that mid position. So if it is the key element is less than your value which is in the mid position, then obviously your search, you should concentrate on left side search. If your key element is greater than your value in the mid position, then obviously you have to concentrate your search on left side. So for example, I'm having 1000 elements, okay, 1 2 3 4 till 1000. Imagine that these are the numbers. I want to search now 400, right? The number 400 I want to search. In the first step itself, I don't want to, I'm finding the mid element, so obviously it will come 500. In that first step itself, I can skip the second of array. 500 to 1000 I can skip because I found the mid element and I'm damn sure that the element which I'm going to search definitely will be in the first stop because it is less than my mid element. That's all the concept, right? So in this session, we have seen linear search and binary search. Both have its own advantages and disadvantages. Thank you everyone. We will see next class with a new topic. Thank you.